I would like to know in terms of what exactly you are witnessing in the industry as far as AI workloads are concerned.
That artificial intelligence has to be added in our data center monitoring and decision making.
In the design or during the construction, what are the things which is getting impacted?
Nobody from the facility team was allowed to enter into the white space or data center. Now we are bringing water up to the rack or chip level.
Once you build a data center, it lasts for another 20 years. So how operators are going to leverage their existing data centers?
You have to either increase your cooling capacity.
So how are you able to accommodate the backend systems in terms of chillers or power systems, DG and all those stuff?
At the time of design, we are using diversity around 70%. Actually, when you see that 100% white space is covered, load is never going more than 40%.
If somebody, your CEO comes and tells you that this data center is designed for 30 megawatt and you have to make it 50 megawatt capacity.
This AI machines have trend to start or stop. Start very fast, start throwing air and stop.
Hello industry friends and colleagues. Welcome to Data Center Guru Talk podcast and expert perspective, where we invite industry veterans and we dwell into the details of the data center life cycle. We delve into insightful discussion on data center technology and the entire different stages of the data center life cycle. So today we have Mr. Sanjay Kuntal, who has been in data center industry for last 29 years, and he has worked for big company like TCS, Thomson Press, Sterling Wilson, Yota, and he has been instrumental in completely managing the life cycle of the data center. And I have personally also interacted with him in a couple of projects where he has been able to solve very complex problems and take to a conclusion. So today, as a part of this DC Guru Talk podcast and expert perspective, this is the first episode which we are recording, and today's topic is impact of artificial intelligence on data center. Because if you look at today, there has been a lot of AI workloads being planned and even being deployed in the data center. I will give you a brief about AI. So when we talk about the basics, every living thing which has been there on earth, they are born with certain level of intelligence, and they use that intelligence to absorb from the environment, and they act accordingly and survive on earth. So artificial intelligence is something which conceptualized somewhere is in 1950, and now it has got matured enough where we are trying to make machine intelligent to take certain decisions based on observations. So typically how we build our intelligence, if you look at the living things and even human, is typically a learning cycle. When a human is born, they are not born intelligent. They are made intelligent by learning from the environment, from supervised learning, like we go to the school and learn. And then all those learnings get recorded in our mind, and our decisions in life all gets coordinated with our mind, whatever data which has been recorded. AI has been built on the same philosophy, where we make the machine learn from the different environment so that machine can take decisions which is more approximate and more effective way of doing certain works. So coming back, as I said, this industry is going through a major transformation where uh, the data center workloads or power density of per rack in the data centers are increasing multifold. So when we look at evolution of data center, what we found is we started with 1 kVA, 3 kVA, And when cloud adoption came into the picture after 2010-15, we were at 10 kilowatt, maximum 15 kilowatt per rack. Now with AI coming in, we are looking that as a kind of a disruption when you look at data center life cycle, where the rack power density is typically becoming multi-fold, which starts from typically 40 kilowatt, goes up to 200, 300, and may go up to even 600 kilowatt. So now I would like to know from Sanjay, where he has been directly involved in design, build, and operate of the data center. He has also been interacting with their customers, who are the typical owner of deployment of AI workloads. So, Sanjay,
Yes.
I would like to know in terms of what exactly you are witnessing in the industry as far as AI workloads are concerned.
So you rightly mentioned in your opening statement, earlier data center was 3 to 6 kilowatt per rack, and when cloud come into the picture, it will go up to 10 or maximum 15 kilowatt per rack. So maintaining a data center up to 15 kilowatt was easy with the air cooled system. Now it is going up to 40, 50 kilowatt into to the air cooled system, and up to 500 kilowatt, 600 kilowatt in coming in future for liquid cooled system or DLC system. So entire scenario of the data center design is getting changed because of this increased demand load of the data centers. Power topology, earlier we are using 2 PDU in rack, but feeding the power up to, let's say, 100 kilowatt per rack or 200 kilowatt per rack, 2 PDU will not be sufficient. We have to put multiple PDU. Power topology will go to change to feed this much load per rack. Same thing for the cooling perspective. Air cooled system cannot feed more than 50-60 kilowatt. If we are going beyond 50-60 kilowatt, we have to go for different cooling systems. Now in the data centers, on AI, we have H100, that is air cooled system, H200, that is air cooled system. For the air cooled, we are going up to 50-60 kilowatt, and we are using different technology, which is new for the data center. Earlier we are using precision air handling unit or high wall units to maintain cooling of the data center. Now we are going for in-row system or RDHX system for air cooled. Coming to the next level, when we are going more than 60 kilowatt, we have to go for DLC system, direct to chip, where water or cooling fluid will go close to chip. Water will flow in the racks, and this technology is being adopted in the data center industry, and it is going up to 500 kilowatt per rack. And other things in air cooled, because we cannot go more than 30 or 25 degrees centigrade of the room temperature. When we are entering into that DLC, temperature of the water going to the rack or chip will be 45 degrees centigrade, and delta T will be around 15 to 18. So return water from the rack will come around 20.
So it is good, no? So when we talk about raising the temperature, water temperature, in that case, obviously it is going to help.
So that will help to save power for the cooling.
Yes.
So industry is getting changed almost 360 degree. So entire topology of cooling power is getting changed. And one more thing which people are not focusing on, that artificial intelligence has to be added in our data center monitoring and decision making. Because when you have load of 10-15 kilowatt per rack, your response time, if 1 minute, 2 minutes, will be okay. When you have very high dense data center, response time should be in milliseconds or seconds.
So exactly what we are looking at is, if you just do some kind of detailing, and obviously when you look at data centers, there are different systems. You have got civil, structure, architecture, electrical, mechanical, and automation layer, safety and security. So this typically AI workload, what are the systems in the design or during the construction? What are the things which is getting impacted, where we have to relook at to see that it is, aligning with the AI workload requirements?
So first of all, monitoring of the temperature, power, all the parameters should be integrated with the intelligent system that can make decisions faster. Other things, when we are coming from traditional data center to AI data centers, rack loading. Earlier weight of each rack was around 500, 600 kilogram. Now it is going up to 1500 to 2
2,500
Yes.
here, what we will learn.
So these all the parameters, pipe size, because earlier nobody from the facility team was allowed to enter into the white space or data center. Now we are bringing water up to the rack or chip level.
Right.
So this is the major change. So facility team and design team or IT team has to work together.
So let us get into the specifics.
Yeah.
So if I look at, are our architectural view of the building getting changed
Yes.
with AI load?
Yes.
So what is that?
First of all, you have to increase that loading capacity of the building. One thing.
So that is a structural part
The
of
structural
it.
part.
Yes.
And other architectural part. Earlier in the data center, because we have less density, now we have high density. So white space versus facility area. Earlier it was 50-50. Let's say
Right.
100 square feet white space, 100 square feet facility space.
True.
Now it is required 3 times of that.
Yes.
Because facility space, we need more UPS, we need more chillers, we need more gensets.
Yes.
So this architecture will change according to the density.
So what you are saying is there would be impact on the this structural design of the building,
and architectural design.
and there would be change in the topology of how the power and the cooling distributions are there.
Yes.
You are also talking about the technology of the cooling, which is going to be there.
Yes.
But next question is, obviously this data center industry is not new. So the operators have already built data center, multiple data center in the industry. And as you know, once you build a data center, it lasts for another 20 years.
Yes.
Now this change has come.
Yes.
Now, so how operators are going to leverage their existing data centers? So how they can be able to adapt, or they can allow their customers to deploy AI load in their existing buildings of the data center? What are the key changes, things we need to do as a part of this process?
Yes, that's good. And this will happen in the phases. First thing, even though our AI load is also coming in phases. First, we got air-cooled GPUs. Now, we are going to get DLC based. So, in the air-cooled system, if you have existing data center and you are to accommodate GPUs in your data center, you have to either increase your cooling capacity by using RDSX, because you are using chilled water pipes across the data center. But now you have to bring that chilled water pipes into the below the rack and connect with each rack, or in-row machine, either RDSX.
Right.
And total capacity, which is dissipating heat outside, that either chiller or cooling tower, whatever you are using, you have to increase capacity of that outside of the data center. And power topology, earlier by default we are using N plus N system. Now in the GPUs we might have N plus 1, 3 plus 1 or 4 plus 1, like that. So UPS has to be distributed in the distributed redundancy, DR.
Okay. So entire UPS topology will change.
DR,
the way
we have to make it.
Okay. So do we get any challenges while we do such kind of changes in existing data centers?
Not much challenges are there, because depth of the rack. Industry, we are using 1000 mm depth of the rack, or 42U. When we are going for high dense rack, depth of the rack we increase up to 1400 and add RDSX behind it. So total depth of the rack will be around 1750 mm.
Oh, so entire layout plan will change.
Layout plan changed. So and lighting layout, whatever we have light that was in the cold air or hot aisle, that is also changed. All the sensors we installed in the hot aisle or cold aisle, because that aisle shifted here and there, So these all the things was changed. But it is doable. There are different technologies. If you don't want to increase depth of the rack, you can use in-row.
So in typically in existing data centers, let us say you planned a building for 30 megawatt or 20. This is the average building IT load capacity which is being built earlier. So 20 to 30 megawatt majorly, if you look at.
Yes,
So now when you add AI load, obviously as the power densities are increasing, so obviously the overall building IT load will increase,
definitely.
right?
Yes.
So how are you able to accommodate the backend systems in terms of chillers or power systems, DG and all the stuff? How are you going to?
So we did two things. In the traditional data center, diversity at the time of design, we are using diversity around 70%.
Hmm.
Actually, where you see that 100% white space is covered, but load is never going more than 40% or
Yes.
50%. Hyperscaler is going up to 45%, but colo always be around 20 to 30% of the load.
Right.
So we use that diversity to feed our AI load. One thing, we add some more chillers. Earlier we planned, let's say, 400-ton chiller on the terrace. That was 24. Now we increase the chiller capacity.
Of the chiller. Okay.
We are going for 500-ton chiller. Number is same. And header risers for the cooling.
Hmm.
That was designed for 30 megawatt. Now you have to feed 50 megawatt or 55 megawatt.
Right.
So we add some headers for the upper floors.
Okay.
With different chiller banks. So these changes was done thoughtfully. Add some more DG sets.
So only thing is that you have to have space to
accommodate these things.
Because the capacity on the chiller, let us say you have 400 ton chillers, you increase the capacity, so obviously number of chillers will reduce.
Yes.
But obviously some delta increase in size would be there, so you can be able to accommodate.
Yes.
But what about the DG set?
DG set, we find another space close to building to accommodate more DG set. Earlier we are going with the LT DG sets. Now because distance was increased, we are going with the ST DG set.
Okay.
So we will not have losses during the transmission of the power. So these all the changes was done, and we successfully increased that building load from 30.6 megawatt to 55 megawatt.
That's great. So this experience we would like to hear from you more in detail in terms of how could you do it, because if somebody, your CEO comes and tells you that this data center is designed for 30 megawatt and you have to make it 50 megawatt capacity, it's really a challenging task where a lot of loads has already been occupied, workloads are already running in the live site. So what is typically, what we would like to know is typical, obviously you must have prepared some roadmap, some kind of methodology which you have followed, and then you got into the detail of the designing of such changes and implementation.
Yes,
so if you can be able to share some experience that will help our audience over there, the industry colleagues, to really learn from it and use it to their advantage.
So right. So Mr. Singh, our CEO given a open inputs in starting of the AI load. He given clear understanding. All the floor above 8 floor will be used for the AI, and he given number of how many GPU he is going to use. Based on that, we calculated total power, and we use diversity of the colo load. So total cooling load, how much will we need to add, and how much DG or UPS and other infra we need to add. We calculate everything, given some space requirement, find out the space, because this was the brownfield project. This was designed for IT building.
Yes.
So we have lot of parking space as per ITS rules. So we utilize that space, because in the data center we don't need any parking.
Right, absolutely.
So we use that space for.
So it was there on the ground floor? Or?
Yes, yes, it is on the ground floor.
Okay.
So we utilize that space for the additional chillers or DG sets, or and in this building, from initial topology, we plan alternate floor for the data center and services. So we have ample space for the UPS on alternate floor. So that was thoughtfully designed because we got the input how much we can go maximum. Based on that, we did all the calculations, space planning, and what is the infra required, how to accommodate that. We did CFD analysis because when you are increasing uh, heat load from 30 megawatt to 55 megawatt, there might be changes in the environment, local environment. Heat rejection by DG set will impact your chiller performance.
True.
Like that. So we did that entire engineering for that particular island. So it is not impacting each other. Based on that, planning was done, and now this is successfully being implemented.
So how did you implement it without impacting your live operations?
Yes.
So what was the planning and how it was executed? Because the risk of getting your data center down whenever you are doing certain changes on the upside or even downside or even certain part of the same floor where data center is live. So how could you able to manage that risk aspect of it?
Yes, good. Uh, when we are planning data centers for colo or hyperscaler, we always consider redundancy and add on how to do it. In the power side, it is quite easy to do, but in the cooling,
Yes.
it is little difficult. But we have tappings on each floor from the riser, and temperature for GPU, temperature requirement for GPU and colo is different.
Yes.
We are using heat exchangers to elevate the temperature. So that was thoroughly did the design, but we have some constraints also, to be very frank. When we are changing one facility to AI facility, so engineering wise, we are not able to justify PUE because we have to accommodate in the existing system. Because this is air cooled, we are not able to elevate the temperature and all because chiller bank is one. So PUE was little compromised. It was designed earlier at 1.43. We are delivering 1.43, slightly less because of the PAHU load, because we are using RDHX.
Right.
And new project which we are planning now, that is greenfield. In these data centers, we are going to use.
No, we'll come to greenfield now later on. On the existing part is very, very crucial and important. So we would like to dwell more into it in understanding. So you have obviously planned, created roadmap, follow the strategies, and then finally you rolled it out. So can you be able to? I will not ask you to talk about your confidential information, but can you be able to talk what is the power load density in your existing data center for which you built, and what is that technology which you have used to support the AI load?
Yes, for existing data center, we upgraded cooling system towards rear door heat exchanger. Two type of rear door heat exchanger available in the market. One is passive, that can support up to 32 kilowatt per rack.
Right.
Another is active.
Yes.
So we can go up to 65 or 70 kilowatt per rack. Because time constraints was there, our CEO is given a mandate. You have to start using GPU in 4 months. So we modified floor layout. Our pipe size for the riser to data center hall was whatever the size, we increase that size. Lay all the pipe in below the floor. As I said earlier, it was not allowed to any water should come into the data center. Now
Right.
we are going up to rack.
So we have to be more secure and safe.
Yeah. It is demand.
Yes.
Safety is one aspect. Demand is one aspect. We have to meet the demand first.
So risk we have to mitigate.
Yes.
Whenever we are building, water is now getting into chip level. So,
yes. So we bring that chilled water up to the rack level. Other challenges now we are our temperature design was for the comfort or data center cooling. Chilled water temperature is less than dew point temperature.
Oh.
Another challenge, when you are using RDHX, and chilled water temperature is less than dew point, then you have challenge of condensation.
Right.
And this AI machines have trend to start or stop. Start very fast, start
stop.
throwing air and stop. And when water temperature less than dew point, then it will condensate inside of the radiator.
Right.
When GPU start, it will throw this
Through water, yes.
in the next row. So we did some mitigation for that. We use levers, so water should not go into the next rack. We use drip tray below the RDHX, so all the condensation will go into the drip tray. These are all the inventions or
learnings
we did, because we are using RDHX since long.
Right, right.
And there was no drip tray because temperature was always above the dew point.
True.
So this all was the learning.
So this is active rear door heat exchanger or passive?
These are active rear door heat exchanger,
which you have used.
Yes.
Okay.
And
so,
very efficient.
So one learning is that condensation aspect of it. So can you be able to share few more learnings, whatever you have got through this process of upgrading your data center to meet AI workload?
Same. And because this load is not, GPU is not come along alone. This is need storage. You need network racks. Network rack have very less load, cannot be cooled with the RDHX.
Right.
Storage have around 15 to 20 kilowatt. Maybe use RDHX or may not be required. So some racks will not have RDHX. So we have to use perimeter cooling also.
I see.
To cool those racks which doesn't have RDHX. So this is got hybrid cooling.
Yeah, yeah.
Another thing, power distributed topology for GPU will have 4 working, 2 standby.
So in your air cooled system also the same topology is there.
Yes.
For
perimeter cooling and RDHX both. This was for the cooling. And power topology, now I am coming to that.
Right.
GPU have 4 working, 2 standby power source. So earlier we have n plus n, 2 PDU per rack. Now we add another PDU into the rack. So 6 source will fed through 3 rack PDU. If one fail, 2 will take care. So all the GPU rack have 3 source and other load.
So irrespective of it is air cooled or water cooled, this topology, power topology applies.
Yes.
Right. So entire UPS topology is changing. Yes. Absolutely. Right. N plus N topology to 4 plus 2
for
topology.
GPU and N plus 1 topology for the UPS and for the rack, network racks and storage racks. You have to go with the
same
traditional N plus N.
So because they have got only 2 power sources.
So this is also been upgraded for using this. And all the calculations, as I said earlier, that diversity. GPU doesn't have any diversity.
I see. So it has got peak or zero.
Yeah. So we have to do all the design or implementation up to 100% or 90% of the TDP.
Maximum load.
Yes.
Oh, this is a very good input. Now coming back to the future. So when we talk about the new building, because demands are there, new data center buildings are also being constructed. But at the same time, AI workloads are not 100% dominated. So AI workloads are coming at the same time, cloud workloads are also there, and other workloads are also there. So now the operators are also in the same dilemma. How do we build, design and build the data center building, which will take care of this AI animal also, and also the existing workloads, whatever is going to come in the data center. So what is that key philosophy on the design aspect of it? I would say, in my terminology, I say future proofing of the design to take care of such technological disruptions, whatever come in the data center. So can you be able to throw some light or talk about for our industry colleagues that they should take care of while they are designing the data centers?
Yes. GPU, which is coming, new age GPUs, are coming with the DLC system, but again, it is not 100% DLC. Generally, NVIDIA is claiming GB200 is coming around 87-13%. 87% DLC, 13% air cooled.
Same GPU.
Same GPU, because in that same rack, apart from GPU, you must have network
Yes.
switch.
Yes. Switch would be there.
Yeah. So 13% load will be air cooled in each rack
Okay.
of the GPU. Apart from this, you have separate network rack, IBRIX racks. You will have a storage.
True.
So almost 25% load will be air cooled, and 70-75% load will be DLC based.
Okay. So you need hybrid cooling.
Yes. Now, designer have another challenge. They have to increase efficiency of the data center.
Right.
When you are to increase the efficiency, you have to use DLC with the uplift temperature. DLC required 45 degrees centigrade inlet temperature to CDU. That can be managed with the.
So as we are discussing on the DLC aspect of it, so I would like to know for our audience perspective, what are these different cooling technology which is there, which is more relevant for our AI requirements, and how you are selecting those technologies?
Yeah, well said. So heat generated by GPU is very high. Either you have to increase that heat sink size bigger, so you can cool with the air, or another technology which adopted by the industry to increase the efficiency of cooling. So chip, they are using a jacket along the chip where chilled water or fluid will be circulated across the chip in that jacket. That is copper jacket where chip will be inserted. So all the heat generated by chip will be transferred to that jacket, and this cooling fluid will extract that heat and transfer to CDU. CDU is another device where facility water and cooling water of chip will be.
So in DLC or direct
to chip,
direct to chip liquid cooling, in that case, typically instead of air being a heat transmission media, we are using liquid. Which is much faster of
heat transfer.
So that way they are able to support.
Yes.
So in that case, up to what kilowatt we can use air cooled system, and what kilowatt we need to use liquid cooled system? Is there any benchmark or any calculations which we can be able to do?
As of now, which servers are available in the market, we can go up to 236 kilowatt per rack. That servers are going to launch by NVIDIA shortly, probably by end of this year. So 236, and future which being planned will go up to 500 or 600 kilowatt. Robin Ultra, again it is going to come in the market. So 500-600 kilowatt per rack with the DLC system. In the DLC, as I said, our topic was how that facility will be holding GPU as well as colo both. So I am coming to that topic back. As 25% load will be air cooled, so we need air cooled system. And to get the efficiency in the cooling system, our 75% load will be cooled by dry cooler or liquid cool system.
Yes.
Either industry peers can use two systems together. One is dry cooler based. It is dependent on which geography they are using. It is in where temperature is not going more than 40-45, then on those places we can use dry coolers. Otherwise, we can go for the chiller or trip cooling. So they have to use both.
So one more thing which is coming to my mind is, in the liquid cooling, there is a lot of talk immersion cooling.
Another cooling method.
Yes.
So liquid immersion cooling. One is DLC chip based.
Yeah.
Another is liquid immersion cooling. That is also in the DLC we create a jacket of copper plate where liquid is circulate in the jacket.
Yes.
But liquid immersion cooling, we paste that chip on that one plate and dip into the coolant,
Okay.
and that coolant will dissipate that heat and transfer to the.
So, what is adaptation of such technology in our part of the world or even across the world? Can you be able to share some view on that?
As of now, DLC is most widely
Mostly
used,
used as of now.
and liquid immersion cooling, it is more efficient because we remove the DLC. We are using fan.
Yes, yes.
Capacity of fan will reduce, but we are using fan. But in the liquid immersion cooling, we'll remove the fan. If your server have 10 kilowatt,
So that energy consumption will also reduce.
1.5 kilowatt or 2 kilowatt will be the fan capacity.
Right.
If you reduce that, so in the liquid immersion cooling, fan load will reduce, even heat dissipation will remain same, then you will get PUE around 1 or 1.05 because you reduce that fan load. But in DLC, you are using fan, so PUE, power utilization effectiveness, will become 1.1 to 1.25.
So that's great.
And air cooled system, generally it is 1.4 to 1.6 in the industry.
So in fact, immersion cooling is, you are saying, much efficient in
Yes.
terms of whenever we use the technology.
Yes.
But as of now, that technology has not been much adapted in
Much
the industry.
adopted, yes, correct.
Right?
Because
Maybe-
a reason of this, which I understand from the hardware manufacturers, because day to day we are working. So hardware manufacturers are not, what we can say, comfortable with this. Removing fan, doing the changing all the configuration, warranty, guarantee, what kind of liquid they are using. So this discussion is going on.
Mhm.
So that development is still going on, and industry, lot of people are there, which they are converting that hardware into the liquid cool hardware. So they are trying to give confidence to the hardware manufacturers. No worry, our liquid which we are going to dip all the servers is very good.
Yep.
It is not going to compromise on that quality or life cycle of the hardware.
Right.
So this confidence,
Yes.
adoption of this
So
technology
it
will
is
take little time.
more of a psych problem,
Yeah.
not a scientific issue.
Yeah.
Right. I remember in late 90s and early 2000, customer used to say, "ये chilled water वाला pipe नहीं जाना चाहिए data center. I don't want." So nowadays, you chilled water piping going through the data center everywhere, cooling and all those stuff.
So simply that
So it is more of a psych problem rather than a real technical issue.
requirement is allow all the inventions.
Right.
Earlier rack load was less. They are not allowing facility people to go into the data center. Now they are, or water, they are scared of the water. I know some of the industry players, they are big in the data center industry, but they are not allowing to install any PAC units close to data center because water condensation will come.
True, true.
So, but now there is no method to cool this much high dense power.
Right, right.
So we have to use that, and I'm sure in next not more than 1 year, people will start used on this liquid immersion cooling also.
So when we talk about this new data center design to take care of the current scenario where hybrid load, which you are talking about, cloud load also, and even if it is AI load, there are certain percentage of air cooled requirement which is there, so which we need to design. So obviously, when we talk about so much of power density for data center, how the PUE is getting impacted overall? Because if you look at global average PUE is around 1.6, and it hover around based on what technology, how you are operating, and how you have designed and everything. It goes up to 1.4. I have designed a system some in small data center where we got PUE up to 1.3. However, we were targeted for 1.2 and all, but we didn't. But when we talk about such high load, how is the PUE impact which is there, whether positive or negative, and how is it? How it is positive and how is it negative?
Yes, when we are going to have a AI factory in 100 megawatt or 200 megawatt, one data center size will reduce. Earlier we are using n plus n system, so distribution losses was whatever losses into 2. Now we are using n plus 1, so losses will reduce, and most of the distribution infra will come close to data center, that losses will reduce. We are adopting different cooling technology, elevating temperature of the data center. Even though this is
So what is that temperature? Because normally we set a room temperature of 24 to 26 for normal data center. But for AI data center, what is the normal room temperature
room
required
temperature, as per S-ray, 27 to 30 we can fix
for AI?
for AI.
Okay.
Now again,
No, not room temperature. That liquid water
look at
temperature. Let us put it that way, because that is more
no, no, no,
important.
no, no. Now I am telling two things. One is the room cooling system. For the room cooling system, we have to use water temperature around 24 to 30 to cool that room up to the comfortable level.
Right.
Another thing, liquid which is cooling GPU load going to CDU and cooling that GPUs, that liquid temperature of facility side will be 45 degrees centigrade, which is entering into the CDU, and return will be around 60-63 degrees centigrade. So two type of cooling. One is the facility cooling, comfort cooling for the data center hall, or mission critical cooling for the data center hall environment. That will be different. That will be 25%. Another 75% cooling will be high temperature system, where we can use dry coolers, cooling towers. So there is no, most of the geographical condition of the country, there is no use of chiller for DLC. So we will have PUE in the GPU data centers using DLC, and comfort cooling will be around 1.25 or 1.2.
Oh, so there is a big PUE improvement.
Yes.
I would say.
Yes.
Right. That's a good news.
And when we are going liquid immersion cooling, then PUE will again, data center will be more efficient, and PUE will be around 1.05 to 1.5.
Now, what is that tips you would like to give it to the industry when they are dealing with such kind of situation of deploying AI workload in their existing data center, or while they are designing a new data center to support AI load or hybrid environment? Just a few pointers in terms of tips.
First of all, AI data center cannot be designed alone. Facility team or design team have to closely work with the IT team, understand that hardware requirement properly, even though they have to go in the detail, what is the CFM, what is the TDP, how much is the size, how to do the maintenance. These all the aspects has to be considered while designing data center. Second thing, GPU load is not normal load. It is hunting like anything. It changes in the milliseconds, go on the peak, go down, peak, down, like this. So our all the power infra should be
Has to be
capable to handle these
peak load.
huntings. Peak load, obviously everything is designed on the TDP, but changes in the TDP, all the time changes in the load is also is considered as a hysteresis, or you can say that changes will create a different frequency. All GPU is keep on changing on the same frequency. This will create a resonance. If you remember that generally army, when passing a bridge, they are not allowing them pass in the 1-2-1-2 drilling. If all the GPU load change is synchronized, that is called sub-synchronized SSO, sub-synchronized, I forget that name, oscillations. That will allow trip to grid.
Okay.
These oscillations is passed on to grid. Grid will not understanding what is happening in the load.
I see.
If your load is in 100 megawatt, 200 megawatt, and local grid will not understand what is happening in the load, going up, down in the milliseconds or seconds. So these things has to be keep in mind, how to damp that up and down of the load. Last thing, this high density load will not allow people to manual response. So redundancy or failures of the system,
Automation has to be there.
Automation has to be there. Automation not only for the monitoring, for the response also.
Right.
Fire system should be designed according to that. Power system, cooling system has to be react very fast according to the requirement of the load.
Mm.
So these are the basic inputs I want to give. Closely working with the IT team, understand what is going to host in the data center. Complete understanding will provide a proper design, and autonomous response has to be keep in mind.
Great, Sanjay. Thank you very much. It was actually pleasure, discussing with you, taking your really knowledge and experience, what you really felt on the ground, and sharing this to this forum, which we would be sharing to our industry audience or industry friends and uh, colleagues. That will be really beneficial to them. And thanks.
Thank you, NK Singh ji, and I really appreciate your initiative, because we have a lot of seminars and webinars, but these sessions, knowledge sharing sessions, are not being recorded and not uploaded anywhere. So some limited people are getting advantage of that. If you are recording this kind of podcast, that will be go into the industry and people will learn from these podcasts, and everybody can share their what lesson learned in their past project, what they are doing in the
Yes.
future. These things will be shared, and people will take
So
advantage of
that's the role of DC Guru Talk, bridging the knowledge gap between the experts and the learner, so that learner can become expert and then he starts sharing their knowledge.
Thank you.
So
Thank you very much.
thanks. So dear friends, you have heard the experience what Sanjay has shared on handling AI workloads from design to build cycle, its advantages, different elements of managing the AI workload, different elements in terms of whenever you have got existing data center, what are the different aspects which you have to take care of to make your existing data center aligned with the AI load requirement. And also we also discussed about the different aspect which you need to consider in your new data center designs to make future proof design which can accommodate a different technology which is coming on around the data center. And I hope this session would be very, very fruitful to you. We would be looking for your feedback, comments, and encouragement in the entire journey, and that will help us making more podcasts with our industry expert and share that experience with you. So thank you very much. We'll come back with next podcast and catch up. Thanks.